On in previous video I have discussed about the vergence and about a wavefront and about the power of the surface, and in this video we are going to discuss about the vergence relationship, how we gonna calculate in some few formulas and all these things, which is very helpful in case of clinical uh, case discussion. If you want to understand contact lens and all these things, these calculations are far important than you can even imagine. So you have to understand the basics, and it will always come back when you go higher and higher and higher. So let's start. First and foremost, the sign convention, which I have already dealt with. The sign convention, that is, uh, especially we always consider light travel from left to right, and we consider height. If it is above from the x-axis, it's positive, and below from the x-axis is negative in case of height, which is very useful in case of calculation and magnification, because when calculating magnification we have to do magnification with the help of sign. It indicates something. So in case of magnification we use this, but in case of length calculation of distance, it's centrally important that if the distance from lens to focal point, from lens towards, from surface towards the center of the radius of curvature, if it is with the direction of light, it will be positive. If it is against the direction of light, it will be negative. So it's centrally important to understand the sign convention. So it's this surface, we always take distance from surface, and here is the, let's take an example of focal point. Then this focal length is towards the light, so it's positive focal length. If it is this, we take distance from surface towards the center of the radius, then its radius is minus negative distance. No matter what, if it is object here and this is the lens, then object is opposite direction, then object distance is negative. If it is image here, then image distance in positive, because towards the light we take distance from lens, not from object to the lens, not from image to the lens, not from object to the lens. It's centrally important. Many of the students did same mistake. They take the direction from the object towards the lens, and then it's completely opposite. You must understand this concept. So let's discuss with the questions, and we try to figure it out slowly and doing all these things, and I'll try to explain the concepts here. An object is located 50 centimeter to the left of the plus 5 diameter is spherical. Okay, so let's draw it. If it is plus, then we will do this. If it is negative, then we will do this, like of this kind of lens. Okay, so now it's completely positive, and we know it's 5 diopter, so let's take this is 5 diopter plus. An object lies where? Object lies in the 50 centimeter. Let's take it, so this distance is 50 centimeter. This is the object. And spherical crown glass, how far image from the apex of the surface, and if is the image is real or virtual, is erect or inverted. If the object is 3 centimeter, then we know 3 centimeter object height, then we need image height. So it's very simple. First we have to calculate the object vergence. We know object distance, so let's do, this is the object distance. Object distance is 50 centimeter. Do you know object distance in negative? Because from lens to the object is negative 50. We can calculate the object vergence. In object vergence indicated by L, which is 1 divided by 0.5, because 50 centimeter is equal to 0.5 meter, which means what? Simply 2 diopter minus 2 diopter. Because why minus? Because object distance is in minus. So as we move forward, image vergence we always indicate by L dash. Image vergence is equal to power of a lens plus object vergence, which is plus 5 diopter plus minus 2 diopter, which is 3 diopter, isn't it? This is the image vergence. Now it's very much simple. So first we are going to calculate image distance. Isn't it very simple? Because image distance is always inverse of image vergence, which is simple. 1 divided by 3, which is 0.33 meter, which is basically 33 centimeter. So 33 centimeter in what? In plus. So again we know, if it is lens, then plus means towards the direction of light. So which is basically 33 centimeter from lens towards the right side of the head. Somewhere like this. Isn't it simple? So it's very simple to calculate image distance. Now we have many more formulas, but I want to tell you the simple formula that I always use, which is sorry for that, which is basically magnification. Magnification is always object versions divided by image versions and then finished. Don't think about anything. This is it. So which means object versions we know minus 2, image versions we know plus 3. So which means what it happens? Minus 2 by 3. What indicates that minus sign? Now it's very important. Minus sign indicate if object is like that erect, then image is inverted, and vice versa. If it is positive, then if object is erect, image also erect. If it is positive, if object is inverted, image also inverted. But in this case, in the magnification sign is minus. That means, here we go. What is the height of the image, and is erect or inverted? Since the object is erect, image is inverted. Correct answer is this. And this is the magnification, isn't it? 2 by 3. Then we have to calculate image size by what? Object height into image size into magnification. Object height is 3 centimeter, magnification 2 by 3 minus divided, which is minus 2. Minus 2 means what? Minus 2 means somewhere 33 centimeter away, which is this, 33 centimeter away, somewhere 33 centimeter away, and height of the image is 2 centimeter. Because since we have already known in sign convention, let's see, if image is like that, then it's negative. That's why minus 2 is height of the image. So it's really simple. So we have to calculate by step, not just moving forward. But this formula is very important. When magnification coming into the term, object versions divided by image versions is very simple to understand the magnification. Then after calculating magnification itself give you the hint of image is erect or inverted. So it's central important concept that you have to understand. Now come to the second question, which is a little bit difficult but not that much. But let's move to the second questions. That is, an object of 15 centimeter height. Let's take an example of, let's do it like this. If this is the object and its height is 15 centimeter, a height located in 33 centimeter to the left of spherical crown glass that has power of minus 10. So as I've already told, this power minus 10 diopter. Then object is 33 centimeter to the left, isn't it? 33 centimeter. This object distance is definitely minus, because away, because opposite in a direction of light, because the direction of light is always considered from left to right until and unless stated. So glass surface power is minus 10. Locate the image, determine its size. Image is real or virtual? Is it? Image is always virtual, isn't it? For minus lens. So it's finished here only. Is it Is it erect or virtual? The image is real or virtual? Is it erect or inverted? So object in case of minus lens is image is always virtual, image is always erect until and unless there are some cases, but we are not going there. So that more complicated topics. So in this case, it's very simple as we can see. The object vergence we have to calculate, isn't it? 1 divided by minus 33 divided by 100, which means approximately 3 diopter, 3 diopter in negative, isn't it simple? And the lens image vergence is a power of a lens plus object vergence, which means minus 13 diopter, isn't it? So minus 13 diopter, which is very simple. Then we have to calculate what? Image, location of image. The location of image distance is inverse of image vergence. So 1 divided by 13 in minus. What is 1 divided by 13? So 1 divided by 13 is basically uh, what have 1 divided by 13 is basically, I have to see the calculations, but 1 divided by 13, if it is in air, then 1 divided by 13 is 1 divided by 13 is something like that, 2 point some uh, let's complete here. 1 divided by 13, it's 100 divided by 100 divided by 13, so 96 and something like that, 7 8 or something like that, but let it be there. And what is determine is size. And let's take example, determine is size. What is the size? It's simple magnification, isn't it? Which is L divided by L dash, object versions divided by image versions. So basically L is minus 3 diopter, and in case of image versions is minus 13 diopter. So 3 by 13. Isn't it minification because less than 1? And here is a sign of plus. What it indicates? If object is erect, then image also gets erect. So that's why we come to this conclusion, erect. We come to the virtual conclusion. As we know, minus lens is always makes virtual. And the image size. Now isn't it simple to calculate image size? We have magnification, 3 divided by 13. We have object height, which is 15. So basically is 45 by 13. 45 by 30. This is in centimeter. This is the image height. So it's really simple to calculate these things. So let me recap once more. First, you know object versions. It's very important. Second thing, you calculate image versions by doing what? Object versions plus power of a lens, which is simple. And then you calculate image distance. Sorry. Then you calculate image distance. Image distance is what? 1 divided by L dash, isn't it? 1 divided by image versions. Then you have everything. It's magnification, which is very simple. L by L dash, which is object versions divided by image versions. Once magnification comes, it indicates directly if magnification is plus, then if object is this like this, image also is like this. If magnification is negative, in object is erect, image will be inverted. So and vice versa. So it's very simple. Then you have magnification, then you have image distance, then you have virtual or erect. Almost all problems, some simple Vergence relationship, they use such type of question in your examinations and in real life scenario. So this is a simple technique you use, but just finding out step by step. And one thing I have not mentioned here is whenever it comes that image versions calculation by this, if image is formed in another medium, then in this case image distance, you cannot use 1. You have to use something like, if it is water in 1.533, if it is glass 1.50, or whatever medium in which image is formed. In that case you have to understand, you have to replace this. And at the same time, you have to understand, if there is object, then you have to calculate object versions like this, object distance. But if object is in water, then you have to add this. If object in glass, then you have to add this. This is very simple thing you have to understand. Sometimes questions become tricky, and that you make mistake by just putting like 1 divided by 10 and you come to the conclusion, but it's not like that. You have to understand the question. When image is formed in water, So this is the case. You have to understand, you have to understand distance, something like that, whatever. So you have to understand these things. Above the distance, which is numerator, is very important. You here we always consider refractive index of the medium, and that's how students get stuck there, and numericals fail. So you have to understand these small things when you are dealing with the concepts. So lastly, very first time I have discussed about these three books. These are the three books that I always go. This is very good book, which is by Michael P. Keating, and this is best book Stephen S. Schwartz if you want to start optometry. And this is like my favorite book of all time, and and one of the favorite person in optics is George Simili. So this is a great book, but you have to have patience to read all these things. So if you want to start from here, and otherwise these two books are fantastic book. Let me know in the comment if you want any other topics. Otherwise, I'm going to slowly start other presentations to like thin lens, cardinal points, and all these things, and we will slowly move forward. Um, till then, bye bye.